Now we shall see how to calculate the effective access time. This effective access time is dealt with respect to your paging concept. With respect to your paging concept. Paging concept. As you are aware, CPU will generate the logical address. CPU will generate the logical address. Whatever logical address it generates, it will be divided into two things. One is page number, another one is offset or displacement. Offset or displacement. This page number will be compared, or this page number will be present inside the page table. Inside the page table. So here what we can understand is that whenever, here if you see here, CPU generates logical address, that is page number and displacement. Here page number will be always inside the page table or translation look aside buffer table. Whenever the page number is generated, it will come here and check your TLB. It will come and check the TLB. If in case the page number is present, then it will tell it is table hit. Else if the page number is not present here, it will come to the page table and it will check for the respective frame number from this particular page table. And whenever the control comes from TLB to page table, it is called as TLB miss. It is called as TLB miss. After you fetch the frame number, whether it is table hit or table miss, you get your frame number from the respective page number where exactly it is present, and add your displacement address and find out the physical address in order to fetch inside your main memory. Now with respect to this, we will be calculating the effective access time. With respect to this, we will be calculating effective access time. How is it? We will see. It tells that compute the effective access time by considering a paging system with the page table stored in memory. If a memory reference takes 20 nanoseconds to search the TLB and 100 nanoseconds to access memory, how long does a paged memory reference table take? If we add associative registers and 80% of the time all the references are found in the associative register. So how do we calculate the effective access time now? The effective access time can be calculated as effective access time can be calculated equal to, it tells that always it is 80% of the times it is always a hit. That is, it tells that the page table references are found inside the associative registers. Meaning is that if you see in this particular diagram, 80 number of times, that is whenever you search for a page number, when you're trying to check the frame number, always whenever you come and check here, it is 80% of the time the page number is present inside your TLB, So here it tells that it takes, in the question it tells that it takes, if a memory reference takes 20 nanoseconds to search the TLB and 100 nanoseconds to access memory. That is 20 nanoseconds to search the TLB. That is time taken to search here. It will be 20 nanoseconds. And from here, when you go here, it will be 100 nanoseconds. So effective access time will be equal to your hit ratio. That is 80% means it will be 0.8. So 0.8 into the number of nanoseconds taken. So it will tell that in order to search for TLB, it is taking 20 nanoseconds and then further it is 100 nanoseconds. So 20 plus 100 equal to 120 nanoseconds plus your miss rate. That is, if in case your data is not present, that is page is not present inside this TLB, then it will go to the page table here. When it goes to the page table, again the memory taken will be addition. That is again 100 nanoseconds you will be spending here. So it will be 20 plus 100, 120 plus your 100 nanoseconds, 220 nanoseconds. So, and one more thing what you should keep in mind is, it tells that 80% is always a hit ratio. So 100 minus 80. So it is nothing but equal to 20. So 20 times or 20% of the time it is miss ratio. So 20 percentage means 0.20 into your 220 nanoseconds. That is how you have got this. I have already told you. 220 is nothing but 20 for your TLB plus 100 for your page table. Then next 100 for your physical address. So total value will be 140 nanoseconds. 140 nanoseconds. This is how you calculate the effective access time. Next we shall see how to solve a problem using segmentation method. Now we shall see segmentation problem. Similarly, in your segmentation also, whenever the logical address is generated, it is generated in two methods. That is, first one is your segment number, then you will be getting your displacement or your offset value. Now, here if you see that, it tells that consider the following segment table. It is given segments, different segments are given and respective base and length address is given. What are the physical addresses for the following logical addresses? So we need to calculate the logical address. Now how to calculate the logical address? Logical address is equal to base plus displacement. Now we shall see with respect to the first segment 0, 430. 0 is your segment and 430 is your displacement. 430 is your displacement value. Now first how do we do is, as you can see here whenever CPU generates your logical address, you have segment number and your displacement. So you go with respect to in your segment number, you will be having your segment number stored inside your segment table. It will be having limit as well as base values. Now when you check the displacement offset, it should always be less than whatever you have generated the value. Plus add this base value, then you can fetch your physical memory address. So similarly here also what we are going to do is, we are going to first check the length. That is, displacement should be less than the given length. So in this respective problem segment, if we see 430 is your displacement, 430 is less than your first value, length is 600. So 430 is less than 600. It is true. When it is true, then we are going to calculate the logical address. We are going to calculate the logical address equal to base. What is my base value? Base value is 219 plus displacement. Displacement is 430. Totally, I'll get value as 649. This is my physical address for the first particular segment. Similarly, we'll calculate for second one. 1, 10. Again here, 1 is the segment value, 10 is the displacement value. Again, you compare d less than length. So d less than length means it is 1 less than 1, sorry, d is nothing but displacement, 10 less than length. Length of first segment is 14. Length of first segment is 14. 10 is less than 14. True. Now calculate the logical address for this particular value. That is nothing but equal to base value. What is the base value for this particular segment 1? It is 2300. 2300 plus displacement. Displacement is 10. So total physical address value will be 2310. Next we shall see for third one. Third one is 2, 500. Again you compare, same thing, d less than length. So d is 500, displacement less than length of second segment. Length of second segment is 100. Now if you see here, 500 is not less than 100. 500 is not less than 100. So in this case it will be an illegal address, illegal access. So you cannot calculate the logical address. Next, with respect to next segment 3, 400, d is less than length. first condition. D is displacement 400 less than, for segment 3 it is 580. Condition is true. I'll calculate the logical address. Logical address equal to base value. Base value of third segment is 1327 plus displacement 400 equal to 1727. Next, last problem, 4,112. So here again you check with respect to distance, displacement and length. So with respect to displacement 112 less than, what is the length of fourth segment? Length is 96, which is not greater. So again it will be an illegal access. Thank you.